Hello everyone and welcome back. Today we're gonna explore two fundamental concepts in Power BI that are essential. We're gonna be talking about calculated columns and measures. Now, understanding the difference between calculated columns and measures is crucial because they play distinct roles in your data modeling and your data reporting. And by the end of this video, you not only know how to create them, but also understand when to use each one effectively. So let's dive in. And let's talk about calculated columns first. Calculated columns are new columns that are added to your table in your data model using DAX. Right? We spoke about DAX in the previous video. So we basically calculated columns are basically you adding new columns using DAX to your tables. They are computed row by row during data refresh, and the results are stored physically in your data model. And the purpose basically is to add new data that we do not have to the existing tables by performing calculations on a row by row basis. They're very useful to create new categories, combining fields, or performing calculations that need to be evaluated at each individual row. So how do we create a calculated column? Let's create a simple calculated column. Let's go to our table view or our data view in Power BI. Let's go to the let's pick the products table and see. Let's create a simple calculated column. Pick the products table and I just want to create a calculated column that combines the product name, that's product name, let's say it's called product name, and the subcategory key. So I want to just create a new column just for testing purposes. It's really not useful, but create a calculated column that combines subcategory key and product name. We should change this to product name actually. I'm gonna just rename it product name. Shouldn't be product name. Right, so let's add a calculated column. How do we add a calculated column? Selected the table. We are in the products table, and in the column 2 you see new column here. So we click on new column, and I want to just call the new field. So it's if you're familiar with creating with tables in Excel where you create a new column and then you do some sort of row computations to create a new column, this will just be very familiar to you. So I want to call the column, let's just call the column test column, and I want to say equal to so I'm just going to write my formula. I want it to be equal to product name and the product subcategory key. So I'm going to say product name. I can find it here. Cycles product, that's my table, and my column name in the square brackets. To concatenate things, you use the ampersand sign, that's the and let's separate it with a dash, and then we use the ampersand sign again, and we want to concatenate it with the product subcategory key. So the product subcategory key, I can find it here, and if I click on enter, I have the new column. Now you can see it's the product name dash and the product subcategory key. So basically this is a row by row. So for each row, when I say row by row computation, for each row it performs that operation and gives us the result in this particular column. This is a simple way to calculate or to create a calculated column. Now let's create something more realistic. Let's delete this and let's go to the sales table. So this is our sales table. If you remember from our data model, the sales table we are using is the 2019 sales 2019-2020. So let's go to that table here, and I want to create first of all, we have quantity on this table, I have quantity on this table. I want to create a revenue column. I want to create for each transactions. I want to create a revenue column. To calculate revenue, I would need quantity and I would need price. We do not have price here. We can bring in price using a function in DAX called related, but we'll talk about all that extensively. This is just to show us how to create calculated columns. So I'm going to create a new column. I'm going to bring in price. I have price in my products table. If you check our products table, we have price. So you can see I have unit price in my products table. I do not have it in my sales table. But because we've created a good data model where all the tables are related to one another, I can bring in price to this table, which is really not good practice, but I could. So let's create a price column. I say price is equal to, and I'm going to use the related function, related, and I want to bring in price from the products table. So if I scroll down, I'll see unit price from products table, and I bring it in. Now I should have price. So I can see price. And how does Power BI know what price to put here? If you remember from our data model, and this is why you need to ensure that you've created a very good data model, and your data model is sound and you know not reading with errors. If you go to our data model, you will see the relationship between the sales table and the products table. This is products table here. They are joined together by the products key. If you click on it, so you can see they're joined together by the products key. So when we write that, use this related function, what it does is basically searches for where the product key matches the two tables and brings the corresponding price, unit price, like we have stated here. So that's how we have price now. So we've created a calculated column. We now have price. Let's create another calculated column because we want to get revenue. And revenue will be quantity times price, right? So let's create a new column. And then we call the new column revenue. Let's give it a minute. Revenue. Oops, sorry, revenue. And that will be equal to quantity sold multiplied by price. So you can see I'm just now Power BI gives me an option and then I just select the options. This is the column I want to multiply. I'm multiplying quantity sold multiplied by price. And that's a new calculated column, right? So if I click on enter, now I have the revenue for each transaction. So you see for the first transaction, my revenue was 55.72, second was 57.71, and I have for each row I have all that computation for each row. So this is a way of creating calculated fields in Power BI. Now, when do we use calculated fields? One, we use calculated fields when we need to perform calculations that apply to each row individually. For example, what we just did, right? We calculated revenue for each transaction that we have, right? We also use calculated fields when we want to add new data that does not exist in the source data. Again, like the revenue did not exist in the source data, all right? We also need to, we use calculated columns when we need to create new fields for our slicers, for our filters, or to group data in our report, right? So if we want to categorize, for example, I think we did something like that where we categorized, we did column categorization, right? So maybe we are categorizing based on price and saying this is high price, this is low price. We use calculated fields for that, right? And the advantages is that it stores the data physically in our model, right? And then it's easy to create and understand. But one thing you should notice, for each calculated column you add to your model, you are increasing the size of your model, which can impact performance. And for each data refresh you do, those computations, because they are physically in your model, they are computed, and this would slow down the refresh process if you have a lot of complex calculations. Now this is where measures come in, right? Measures are calculations that are used in data analysis in Power BI that are not physically stored in your data model, but are calculated on the fly, right, during your report interaction. So basically with measures, you're not storing those fields in your tables. You're just writing some computations, and then every time you interact with your data, those computations are done. So basically, it improves the performance, right? And measures are specifically used where you want to perform aggregations, right? So basically, measures help perform dynamic calculations that respond to filters, slicers, and other interactions. And they're ideal for calculations that need to aggregate or summarize data. So we've created a calculated field. How do we create a measure? Before we jump into creating a measure, I'm going to just do a quick visual just to show us that we can achieve this revenue by creating measures instead of um, using calculated fields. So I'm going to go to my visual view, my report view, and I'm going to let's create our first visualization. Don't worry about visualization here. We have a whole section for that. Just want to create a quick visualization. We're going to drag products key here, and for each products key that we have in our data, we did create. So this is the revenue we created here. You can see it's a calculated field here. We created revenue. And I'm going to just drag that into the pane as well, so we can see the revenue created for each product, revenue generated for each product. So product 201 generated 164,000, pardon. And this is, again, this was from our calculated field. Remember, we created revenue from our calculated field, but we want to do the same thing using measures. So how do we create a new measure? First of all, in your it's always best to select the table where you want the measure to be saved. And you in your home view, you would find measure here and click on new measure. So it's working on it. So let's call the measure rev. I'm just gonna call it rev so we can distinguish between one we created with calculated columns and the new one. So I'm going to say rev is equal to, and pardon me, I entered enter. I'm not done. I want to create it on a new line, so I'm just going to press shift and enter to go to line 2, just so it's not too long. And what I want to do is use the SUMX function, and we'll talk about all this again in detail. SUMX function basically is used to returns the sum of an expression evaluated for each row in a table, like we can see on the screen, right? So it's different from sum. What sum does is that it adds all the numbers in a particular column. SUMX takes in an expression, performs that expression for each row, and then sums up all the result of that expression. So again, we'll talk about all that in detail. So for SUMX, it takes in the argument, the table. So the table we are operating in is our cycle sales table. And then it takes in the table and it takes in the expression. So the expression I want to do is I want to multiply quantity, which we have. Remember, we have quantity as a native field in our sales table. So I want to multiply quantity with price. So I'm going to just say quantity sold, quantity, and I have the suggestion here, multiplied by, remember, natively we did not have price. We had to use the related function to bring in price. So I'm going to use that related function in my measures. So related, and then the column I want to bring in through the related is unit price, and I'm just going to close it. So this is my measure that I am creating. I've called the measure rev underscore, that's the name, and this is it. So I'm basically summing all the I've created this formula, this expression here will give me revenue because it's quantity sold multiplied by price. Right, so I'm summing everything. So I'm going to just press enter as soon as I'm done with that. I'm going to press enter, and we've created it, so you can see rev here. what I'm going to do is for this visual, I'm going to drag this rev that we created into view so we can look at it side by side. So you can see we have the same values, right? 164 million, 164 million, 85 million total, 85 million total. And we achieved the same thing with two different methods. We use calculated columns, we use measures. But measures have a certain advantage, right? And they are best used when you are performing aggregations, right? That's one. They are dynamic calculations, meaning they are just based on filters that you enter. For example, if I let's take this sum of revenue out first. If I bring in let's filter by something. Let's filter by age group, for example. I'm going to convert it to a filter. So we have a filter for different age groups, and if I select young adults, it's not really filtering. I need to check our model to be sure that we have age group can filter our sales table. Ooh, so this is the problem. So that's the reason why it wasn't really filtering our when we joined age group with age group key. If you see here, that's the issue. So it's age group joining to age group key instead of age group key to age group key was age group. So let's delete this. We're going to delete this particular one and do that model. And this is why your model needs to be good and sound. So let's do this age group key to age group key, age group key, age group key. Yes, this should work now. Because I was wondering why the filter wasn't working. Okay, great. So now we can filter. So you see, we have senior, and we can see for seniors, this is the revenue they generated. For youth, this is the revenue they generated. And this is one of the benefits of having measures, right? They work with filters. Again, advantages of measures is that they do not increase the size of your data model since they are calculated at query time. So they are not calculated every time you will have to refresh, right? And they automatically respond to user interactions, right? So they make our reports more interactive and more insightful. But again, you most likely want to use measures at where you are aggregating with numbers that you are aggregating. So yeah, this basically is everything about calculated fields. You now know the difference in calculated fields and when to use them and measures when best to use them. In coming videos, we are going to now be going into some of these core DAX functions, something like all the ones I've been using, related functions, SumX. We're going to be going into them one after the other to understand them better and see how we can use them to generate insights. So stay tuned and see you in coming videos.